Hi, and welcome back. And right now, this is our second question or second scenario that we will be working on about spring. So we have the same setup earlier, like from the previous video, the most recent one, where we have the block connected to the spring system, and then it is pushed to a certain distance L, just like what is indicated over here. And then you will let go of the block, remove the force that you apply, and then you will let it, once you let go of it because of the spring force, the force of the spring will push the block to the right. Okay, so it will push the block to the right up to a certain point where it reaches. And that point is what we call the maximum distance where it travels. Okay, so of course, because of the inherent property of spring, when this block reaches the farthest part, it will reaches the maximum distance, and from there, because of the inherent property of spring, as I always mention, it will pull it backwards to its original form. Okay, so it will pull it backward to its original form. So now, why don't we figure out the different number one force of the spring? Okay, so what is the force of the spring when you release, when you let go of the force of the block, and then it reaches at the same distance where L, the final distance, is equivalent to the initial length. Okay, so the final length is the same as the initial length, L sub naught. Letter B, what is the acceleration when the object reaches at the same position? What is the acceleration at the same position? Letter C, what is the acceleration when L, right here, the lowercase l, is equivalent to 3L, 3 of this? Okay. What do you think is the position? Okay, so what do you think is the acceleration at that point? And then last but not least, what do you think is the force of spring? Okay, what is the force of spring when it reaches at an L that is 2.5 L away from our um, from the point where it is connected on the wall. Okay. Now here I want to emphasize that in this problem, okay, let us set that friction is negligible or zero. Okay, force of friction is zero, or we can say negligible. Okay, so it's smooth, so you can consider friction force as zero. Okay, so now why don't we start with question letter A? Okay, so let's answer question letter A. Question letter A. So question letter A, this is the point where we have the dot, where we have it here. Okay, so let me just put this x and y coordinate, and now we have this dot. So let's start with a free body diagram. Okay, so the first thing we have is the force of gravity, and then we have the normal force. Okay, and then we have the force of spring. The force of spring is pushing it away from the wall, and what do you think is the force of the spring? So let me just draw it here like this. So now, since there's no friction, so we don't have the friction that is going against against the force along the horizontal axis, which is our spring force. Okay, so there's no friction. So, what is the force of the spring? Okay, so force of spring. Basically, you don't even have to put summation of forces along the x and y axis. This solution is basically just a direct substitution of the equation where you have f of s is equivalent to negative k, that is x, right? And then we all know, and it was discussed in the previous video, that x is simply your change in L, which is your L minus the initial L. Okay, so L, the final displacement, minus the free length. Okay, so the free length right here. Okay, so that's the free length. Now, is it negative or positive? So we have this over here, positive to the right. Okay, now we know our K, which is given as K. Now let's analyze our L. Maybe our L is going to be negative, so negative times negative, it's going to be 0. Negative times negative will be positive. Now, let's take a look at this. So what is the final position? It says L sub naught when it went back to its original position. So we have L sub naught minus L sub naught, because that's our original position. And L sub naught times L sub minus L sub naught is 0. 0 multiplied by K is 0. It doesn't matter if it's negative or positive. So it means that there is no force acting at the original position. Okay. So there is no force acting on the original position, L sub naught. So when this block travels back and now they lined up again, right here, let's say it lines up. Okay. For whatever reason, it goes back. Of course, it's going to go back. It's going to go back like this. So now you have that block over there. Okay. So you have that block right there. That's why you have force of 0 at that point. Now for letter B, what is the acceleration along that line, along that point? Okay, when it goes back to its original location, we can say that the summation of forces along the x-axis is mass multiplied by the acceleration along x. So we can solve for this. But now let's figure out the different forces first. So we can definitely say that the summation of forces, we only have force of the spring. And then we have mass, and then the acceleration. Now we don't know if its acceleration is positive or negative. So what I'm going to do, all I have to do is divide my Fs over my M. Okay. So you divide your spring force by M. Now, I can just say that it's 0, so I'll substitute it by 0. But sometimes, just like my suggestion is, do not rely on the answer from the previous question, because if you made a mistake in calculating or figuring out the answer for letter A and you use that solved answer for letter B, then you have A and B incorrect already. So you always rely on given information. So what is the spring force equivalent to? So that is negative K multiplied by X, or that is delta L over your mass. Now this time we can plug in our answers, plug in the values. So we have negative K, so L naught minus L naught, because that's what it is from letter B. So when it's at the original location, oh, this is 0. So any number divided, 0 divided by any number is going to give us 0 acceleration. Okay, so 0 acceleration. It means as we go over our harmonic motion later, Okay. In our topic about harmonic motion, you will learn that at zero, at this point, the block is moving at its maximum speed. So it's moving at its maximum velocity. Okay, maximum velocity going to the right. Okay. Now for letter C. Okay, so letter C, this time it's 3L to the right. Okay, so 3L to the right. So now we can apply the same concept, use the same. What is the acceleration? Okay, so we can definitely use the same one, which is the force of spring over m. Okay, force of spring over m. Now, the next step is to just look at the value of the force of spring, which is negative k. And then the final one, the final L, is 3L minus L sub naught, which is 2L's. Okay. So L sub naught is 2L. It's right here. So that's the original location. So that's 2L. And then we divided by M. 2L, 3L. So it means what? 3 minus 2. So that is positive. And then now we're going to have an answer that is negative KL over M. Okay. So just like what I mentioned earlier, as an inherent property of a spring, if we have L as our compressed distance or compressed length, original length is 2L, 3L means it's expanded all the way to the maximum length. Okay, so it's expanded to its maximum length. So when it reaches the maximum length, maximum stretch of the spring, what will happen is that it will start to move backward. So that's why the acceleration is negative, because now it's going to start to move the opposite direction, as we all know about spring. Okay, so once you let go of the spring, it will go right, left, right, left, right, left, or if it's hanging, it will gonna go up and down until an external force acts on the object and it will stop it from that motion. Now, last but not least, letter D. So we can simply use the same strategy of solving it, and that is acceleration, or I'm sorry, let's figure out the force of the spring. We're not solving for acceleration anymore. We're solving for force of spring. Force of spring is simply equivalent to negative K multiplied by X, which is our delta L. Now, we all know that that is negative K, and then our final length is 2.5 L minus the original length, which is 2L. Now that it's 2L, so we can say that our force is negative 0.5 K times L. So it means that the force of the spring when it reaches 2.5, okay, 2.5 of the length, because earlier it was 3, it's 0 when it reaches the end, okay, not 0, 0 acceleration, so it's not 0 acceleration, but it reaches the maximum distance. So what will happen is that it's going to start to move backwards to the left. Okay, so backwards to the left, that's why it's negative acceleration. And for you to have a negative acceleration, so the force should be pulling it back to the left also. So since now it's going to the left, it will continue, it will stop from going to the right, and it will be pulled back to the left. Okay, so that's a different way of analyzing our spring. So here's another example. Hope you like it, and then we'll be working on another example in the next video.